Today we are discussing about geometry, unit 5, congruent triangles, the third skill, which is about proving triangle congruency by SSS and SAS. So in the previous videos, we discussed about congruent triangles, how to identify congruent triangles, and how to write the congruency statement, and to identify the corresponding parts from the congruent shapes. In today's video, we'll be discussing about how to prove two triangles are congruent by two theorems. We could either use SSS or SAS depending upon the triangles that we are given with. So let's say we have two triangles like this, and we have one hatch mark for these two sides and two hatch mark for these two and three hatch mark for the third side. So we have three sides congruent to the three sides of the second shape. So we can say these two triangles are congruent by SSS, which stands for side, side, side theorem. And we'll be having our second theorem, which is about side, angle, side. Let's say we have two triangles and we have two sides that are congruent, and we have a congruent angle, and we have a second side which is congruent to the second side of the second shape. So we have one side, one angle, another side from both shapes. So we can say these two triangles are congruent by side, angle, side theorem. So let's look into some of these examples. Our first problem, we are given with this triangle. Basically, we have two different triangles here. So we need to prove that triangle RSU is congruent to triangle QRT. So we need to prove this. So the easiest way of proving two triangles are congruent are by starting with the given information. So we need to carefully look into the given statement. So in the given statement, it says R is the midpoint of QS. So it is a given statement. And RU is congruent to QT. So after looking into the given statement, we should be carefully looking into the shape. So let's see if we have any similar hatch mark. So if you look into this one, we have one hatch mark for this and one hatch mark for QT, which means RU is congruent to QT. It is given in the shape. And SU is congruent to RT. Why? Because they both have two hatch marks. It is also given in this shape. And QR, we have QR congruent to RS. QR is this one and RS is this one. Why they are congruent? Because R is the midpoint. So this point R divides the total segment QS into two equal parts. So we can say QR is congruent to RS. So now I accidentally click on CPCTC. So we need to find a theorem which states these two triangles are congruent. So the easiest way for finding that is by marking everything just on one triangle, or you can mark on both triangles, but try to focus only on one triangle to identify the theorem. So we already have the given information about the two sides in the in the shape. So we just need to mark the third side. So we already said QR is congruent to RS. So let's use three hatch mark. So now if we only focus on one triangle, we can say we have three sides that are congruent to three sides of the second triangle. So obviously these two triangles are congruent by SSS. So three sides of the first triangle are congruent to three sides of the second triangle. So they are congruent by SSS theorem. Let's look into our second problem. So in this case, it is said that TW bisects UTV. So if a line segment bisects an angle, it divides the total angle into two equal parts. That's why it is written definition of angle bisector. So we have we have one set of congruent side because we only have one hatch mark for these two sides, and it is said that TW bisects the total angle into two. So we have these two small angles which are congruent since it's a angle bisector. It divides the total angle into two equal parts. And now we have our third information which says TW is congruent to itself. So if any segment is congruent to itself, we can use reflexive property of congruency to prove that. If any number is congruent to itself, we use reflexive property of equality. If any segment or angle is congruent to itself, we call that as reflexive property of congruent. We studied this in detail in Unit 2 or 1 of geometry. So now we just need to focus only on one triangle and try to find the sides or angles. So we have one side congruent to one side of the second triangle. We have one common angle and we have one more side. So we have side, another side, and one more side. So we can say these two triangles are congruent by SAS theorem. Let's look into our third example. So now it is said that GH is parallel. So these two vertical lines represent parallel. So they are parallel to each other. We need to prove that those two triangles are congruent. So GH is congruent to EF. Why? It is already given in the shape because they both have one hatch mark. And GH is parallel to EF. Why? It is given in the statement. And now we have an angle. So angle EGH. So angle EGH is this one, and angle FEG is this one. So these two angles, they form an angle pair. So since they are inside two parallel lines on the opposite side of the transversal, so a line that divides two parallel lines are called, the lines that divide the parallel lines are called as transversal. So since we have two angles on opposite side inside two parallel lines, we can say these two angles are alternate. Since they are on the opposite side, we can say alternate. Since they are inside these two parallel lines, we can say interior angles. So these two angles are alternate interior angles. So now we have one side, one angle, one common side. So obviously they are congruent by SAS theorem. Moving to our next problem, it is said that y is the midpoint. So we can say wy is congruent to xy because a midpoint divides the total segment into two equal parts. And from the shape, we can say VW is congruent to Vx because they both have one hatch mark. And our third one is Vy congruent to itself by reflexive property of congruence. So we have one side here, and another side. So these three sides of the first triangle are congruent to the corresponding three sides of the second triangle. So they are congruent by side, side, side theorem. Moving to our next level, we have a couple of information given as a statement. So FG is congruent to HI, it is given. GH is congruent to FI, it is also given. FH is this one. So FH is congruent to FH. So if anything is congruent to itself, if we are saying about segments or angle, it is reflexive property of congruence. If you are saying about an exact value like 5 equals 5 or 10 equals 10, it would be reflexive property of equality, which we'll study in detail in the upcoming units. So now we have three sides congruent to GH congruent to FI, FG congruent to HI, and this one is a common side for both triangle. So we have one side here, another side here, another side here. So these two triangles are congruent by SSS theorem. Our next example, now we have an equilateral triangle. So the first thing that we need to notice is to find the properties of equilateral triangle. So it is said that PQS is an equilateral triangle. So we can say all these three sides, if you recall the property of equilateral triangle, all three sides are having the same measurement. So we can say PQ, QS, and PS, they all are congruent to they all are congruent to each other. So let's look into our option. So you can see this option, definition of equilateral triangle. So we need to prove that triangle PST is congruent to triangle QSR. So PST and QSR. So we have PT congruent to QR. It is given PT congruent to QR. And we said PS is congruent to QS, and it is said that angle RQS is congruent to SPT. So RQS is this angle and SPT is this angle. So if you just focus on one triangle, I'm just focusing on this one, which is PST, you can say we have one side here and we have one angle here, and we have our third side here. So we have side, angle, side. So triangle PST is congruent to triangle QSR by SAS theorem. Now we have our next example. So we need to prove that triangle GHI is congruent to triangle GJI. So we are already given with two information. So GH is congruent to GJ because they both have same hatch mark, and HI is congruent to IJ. They both have like two hatch marks, so they're congruent, and GI is congruent to itself. So if anything is congruent to itself, don't forget it is reflexive property of congruence. So we have one side here, second side here, third side here. So they are congruent to each other by SSS theorem. Let's look into our next example. So it is given that I is the midpoint of EG and FH. So if you notice the first two statements, I is the midpoint of EG and I is the midpoint of FH. So it's already given. So we just need to click on that option that says given, given. And now we have our third row which says EI is congruent to GI. So since I is the midpoint, we can say EI is congruent to GI and HI is congruent to IF. So what we need to look is something that says something about midpoint. So if you closely look into all these options, you can say something that says about midpoint, which is definition of midpoint. So we can use the same reason for these two because it's given that I is the midpoint. Definition of midpoint and definition of midpoint. And now we are only missing one more thing. So we have two sides. We either need an extra angle or an extra side. So our next row says angle EIH is congruent to FIG. So EIH is this angle, FIG is this angle. So do you remember all the angle pairs? So if two angles are opposite to each other, they are congruent and they have a special name, which is vertical angle. So we can say EIH and FIG are vertical angles. So we need to look for something that says about vertical angles. So let's look into all the options. You can see vertical angle theorem. You just need to click on that one. So we have, let's mark everything one more time. So we have one side here, we have our second side here, and we have one angle which is included in between these two sides. So we have one side, one angle, another side. So we can say triangle EHI is congruent to triangle GFI by side angle side theorem. Now we have our next example. It says S is the midpoint. So since it's given, we just need to click on that option. And SU is congruent to SV. Again, that's a given statement. And TV congruent to RU. So see, we have most of the informations here. TV congruent to RU. That is also a given information. We are only missing the third information, which is about RS being congruent to ST. So RS, so let's mark all these stuff. So SU congruent to SV, TU congruent to, sorry, TV congruent to RU. So the last one is about the side RS congruent to ST. How can we prove that these two sides are congruent or these two segments are congruent? We can prove. Why? Because it says S is the midpoint. Since S is the midpoint of the whole thing, we can say RS and ST are congruent. So let's look for something that says about midpoint. So you can see definition of midpoint. So we have one side, second side, and third side. So we have side, side, side. So these two triangles are congruent by side, side, side theorem. Now we have, again, it says that I is the midpoint. So it is a given statement. I is the midpoint of FH and EG. Those two are given. Since I is midpoint, we can say FI is congruent to HI and EI is congruent to GI. Now we are only missing one more side, which is FG congruent to EH. It is given in the statement. So we have one side, second side, third side. What we need to do is we just need to write the congruency statement here. So we have that option to put triangle. So we need to write triangle EHI, the exact same thing, is congruent to triangle GFI by side, side, side theorem. Now we have our next example, which says HK congruent to GK. It is given. And JK congruent to IK. It is also given. So let's mark all these stuff. HK congruent to GK. JK congruent to IK. And we need one more angle or one more side. So it's given that angle GKJ is congruent to triangle HKI. They're vertical angles. So we have two sides and an included angle. So we can say these two triangles are congruent by SAS. Let's put that congruency statement. GJK congruent to triangle HIK by side angle side. Ooh, now we only have one statement and one reason. We need to fill the whole thing. So if you look into the given statement, you can see y is the midpoint of wx. So since y is the midpoint, we can say xy is congruent to yw. So you just need to click on the segment notation and we can write xy congruent to wy segment wy y. By definition of midpoint, they are congruent. Now we have one side. It is said that Vx is congruent to Vy. Let's add a new line and put the same information. Vx congruent to VW. So Vx is this one, VW is this one. So they are congruent. Why? Because it's already given to us. So now we have two sides. We need one more side or one more angle. We cannot prove anything about angle because we don't have enough information, but what we have is a common side. So we can say Vy is congruent to itself because Vy is the side which is common for these two triangles. So let's add one more line and say Vy congruent to itself. Why? So if anything is congruent to itself, we can use a reflexive property of congruence. So now we have one side, second side, and third side. So we can say these two triangles are congruent by side, side, side theorem. So triangle VXY congruent to triangle VWY by side, side, side.